This video is going to cover a general overview of what explicit and recursive formulas are, and then a bunch of practice problems, practicing the skills that you need in order to use them. So let's just quickly review, and then we'll get to some of these practice problems. Basically, an explicit formula is any formula defined by a sub n equals a sub 1 plus the common difference d times, in parentheses, n minus 1. A sub n stands for the nth term, which could be any term in your sequence, maybe the third term, maybe the 10th term. A sub 10 would be the 10th term. That's just what a sub n is generally referring to. A sub 1, that's your first term, the very beginning of the sequence. The variable d is your common difference, so maybe you're adding 5 each time, maybe you're taking away 6 each time, but that's the common difference. And then the other type of formula we have is called a recursive formula, and that is a little more simplistic to define. It is a sub n equals a sub n minus 1 plus your common difference d. Again, the nth term is represented by a sub n, but this thing in the middle, a sub n minus 1, that represents the previous term. Because it says a sub n minus 1, you're going backwards one term. If it said a sub n minus 4, for instance, you would be picking the term that was 4 terms ago, because it says minus. And then again, the variable d is your common difference. Alright, so let's look at some practice problems. Basically, I'm going to go through the first couple of these more in depth and then just go through the explanations a little faster. The idea is that if you need to pause the video, do that at any time. Also, if you want to pause the video before I even start and try to do the first couple problems, that would also be a good idea. But alright, here we go. Number 1. You're just determining if the sequence is arithmetic. It's a very simple thing to do. Basically, you just need to find if there is a common difference between your terms. As you can see, from 35 to 32, you are decreasing by 3. From 32 to 29, you are decreasing by 3. And then from 29 to 26, you are also decreasing by 3. That means this is an arithmetic sequence. There is a common difference between each term, and that common difference was taking away 3. So that's what all these questions are asking you to do. Just see if there's a pattern, and if there is, define the variable d to be whatever that pattern is. So in number 2, we also have an arithmetic sequence because from negative 3 to negative 23, you're taking away 20 each time. And then likewise from negative 23 to negative 43, you're also taking away 20. So that's another arithmetic sequence, and the variable d is representing negative 20. In number 3, again, you're going to be taking away 30 between each of those terms, so this is another arithmetic sequence. In number 4, it's arithmetic because it's taking away 10 each time. Number 5 is arithmetic because you are taking away 2. And number 6 is also arithmetic because you are adding 5. So all of these sequences were arithmetic, and this exercise was just done to really help you see patterns and make sure you're understanding that the variable d is representing the common difference. Now down here in 7 and 8, we're now being given an explicit formula, and we're trying to find the first 5 terms, and then they name another term within the problem that they want you to find. Basically, the explicit formula allows you to calculate any term you want in the sequence without having to know any of the other terms, aside from a sub 1, of course. And you can see that right up here in the top where I wrote down the formula again. That's what's kind of being practiced right now. Alright, so in number 7, we have a sub n equals negative 11 plus 7n. The first thing we're going to need to find is the first term, because it says it wants the first 5 terms in the sequence. So a sub 1 is going to equal negative 11 plus 7, and then because we're trying to find the first term, our variable n is being represented by the number 1. So a 1 will go inside of the parentheses instead of the variable n. And that's how you substitute into these formulas to get all of your general answers. So basically, negative 11 is being added to 7 times 1, which is just 7, and negative 11 plus 7 is negative 4. So we now have the first term of the sequence. It is negative 4. And basically, you're going to keep following this flow as you go through this problem. We're now going to make n2 because we're trying to find a sub 2, the second term in the sequence, and then this time, instead of having an n inside of the parentheses, we would have the number 2 inside of the parentheses. And then 7 times 2 is 14, negative 11 plus 14 is 3, and that is the next term in the sequence. So let's go through this one more time, and then hopefully we will notice the pattern and we don't have to keep using the formula. Basically, we're now finding a sub 3, the third term in the sequence. We're going to make n 3. 7 times 3 is 21, and negative 11 plus 21 is positive 10. Now at this point in the problem, you might notice from negative 4 to positive 3 is adding 7, and from 3 to 10 is also adding 7. That's the beginning of an arithmetic sequence, the pattern that you are going to define all of the future terms by. So really, you can just think, okay, what's 10 plus 7? 17. What's 17 plus 24? Or I'm sorry, what's 17 plus 7? That is 24. And that's the general pattern that you can just use at this point. The last thing, though, we were asked to do is find the named term in the problem, the named term, and the term they named in this problem is a sub 34. So you're going to be plugging in 34 for n, and 7 times 34 is 238. Negative 11 plus that is 227. So that's all you have to do with this type of problem. Let's do number 8 as well, but I'm just going to go through it a little faster this time because it's pretty much the same idea. So again, here's our formula. A sub n equals 65 minus 100 times n. We're finding the first 5 terms. You're going to make n 1. A sub 1 is your first term. So negative 100 times 1, that is negative 100. And then 65 minus 100 is negative 35. So that is your first term. You can then go back and make n 2. So this time we're doing 100 times 2, and that's 200. For the second term, a sub 2, the second term. 65 minus 200 is negative 135. And then again, to now find the third term, a sub 3, that's going to be 65 minus 100 times 3, and that is 300, and you would get negative 235. So again, maybe you'll notice we are taking away 100 each time. The common difference is taking away 100, so we can just now kind of skip the whole formula step and just realize, okay, after negative 235, it's going to be negative 335, and then negative 435. And then lastly, to find the named term, a sub 39, you would simply plug in 39 for n and do 100 times 39, 3,900, and then subtract that from 65. And there's your final answer, negative 3835. All right, now for the back page of the homework assignment. Very similar thing we're being asked to do here, but it's now just involving the recursive formula, the formula where you have to go back and use the previous term. Basically, we are given the first term of the sequence, and we're also given the common difference. We're trying to write the recursive formula, and then the first 3 terms that come after the one they gave us, and that is a sub 1. So we're finding a sub 1, a sub 2, a sub 3, and a sub 4. We're actually going to start with question 20 because oops, there's a little bit more animation. There we go. We're going to start with question 20 because question 19 deals with fractions, and we are not trying to focus on the fraction rules right now, so we will come back to that. We're going to start with number 20. First thing we see here is the recursive formula that I just wrote out. A sub n equals a sub n minus 1 plus the variable d, the common difference. So in this particular case, in number 20, they tell us that a sub 1 equals 39. So that means the general formula, a sub n equals a sub n minus 1, well, we're going to be taking away 5 each time. So instead of writing down d, we're going to write down subtracting 5. And now that we have the general formula for this particular sequence, we can now use it to find the next 3 terms. We already know what a sub 1 is. It's 39. So we're trying to find a sub 2. So that means we're going to have a sub 2 equaling, in the original recursive formula, it says a sub n minus 1, so we're going to write down 2 minus 1, because the variable n is now 2. And we're taking away 5 from that. But just realize that where it says a sub 2 minus 1 is just 1. And that's what the whole recursive idea is. You're taking the previous term to then get the next term in the sequence. But we can now rewrite this to get our answer. It's pretty obvious that we're taking away 5 each time because it says it in the beginning of the problem. But just to do it the way the recursive formula wants it to be done out, 39 is the value of a sub 1, so we're going to replace a sub 1 with 39, and we're going to take away 5 from it, and that's 34. And that's how you prove the next term in the sequence is 34, by using the formula. Is it easy to do? Yes, it is, but the main thing that you need to keep in mind is just that whole previous term referencing idea. So 39 was our first term, 34 is the second term. We're now going to go back and get a sub 3, so we're going to need to set that equal to a sub 3 minus 1, and 3 minus 1 is 2. A sub 2 is 34, we just got it, and 34 minus 5 is 29. Next, a sub 4, we're going to need a sub 4 minus 1, and that would be 3. And then a sub 3 was 29, we just calculated that, the previous term. 29 minus 5, that's 24. All right, so let's move on to number 21 now. Same idea, we're just going to go a little faster this time. Again, a sub n is going to equal a sub n minus 1, and this time we're adding 200 to get the next term in the sequence. So there's our general formula, and now we're going to use it to get our answer. Negative 26 is a sub 1, as it says in the problem. And now we're going to try to find a sub 2, so that's going to equal a sub 1, because again, n is 2, 2 minus 1 is 1. And if you need to rewind the video to go back and look at this problem for that explanation again, do it, because it is the exact same idea that is being talked about right now. And then you're adding 200, and a sub 1 was negative 26 plus 200, that's going to give you 174. And now you go back, we're trying to find a sub 3, so we're going to need a sub 3 minus 1, which is 2. A sub 2 is 174, we just got that one, we just calculated it, and then 174 plus 200, 374. Lastly, a sub 4, you're going to need to take a sub 3, add 200 to it, that's 374, that is getting 200 added, so we have 574, and there you go. Number 19, by the way, just to kind of get the answer out there, this video is focusing on explicit and recursive formulas, not really going into the whole fraction rule idea. So all I'm going to say about this is you had to find a common denominator to take away 1/3 each time, and because the fraction is a 3/5 and we have a 1/3, your common denominator would be 15. So that's why the last 3 terms that were found have, or the 2 right here in the middle, they have denominators of 15. But you basically take away 1/3 each time, and those 4 fractions would be your answer. Let's look at number 22. We are doing a sub n is going to equal a sub n minus 1, and then our common difference this time is adding 0.9. So again, we are going to now find a sub 2, which means we're going to need a sub 1. A sub 1 was negative 9.2, and we are adding 0.9 to that, and we are getting negative 9.2. Oops, 9.2 plus 0.9, there we go. And negative 8.3, that would be your second term now, with the first term being negative 9.2. And then if you just keep adding 0.9, that's the general pattern here. I'm going to skip the rest of this work because I've done it a few times now. You're just taking 0.9, which is the common difference, and you are adding that each time to your answer to get the next answer. So negative 8.3 plus 0.9 is how you get negative 7.4. And then negative 7.4 plus 0.9 is how you get negative 6.5. So that's how those last 2 answers were gotten. All right, in number 23, we are given a term in the arithmetic sequence and the common difference, and we're just trying to write the recursive formula and the 3 terms after the last one given. This is pretty much the same thing that we were just doing. You're just now finding terms that are farther down the sequence. In the previous examples up here, we were finding a sub 1, a sub 2, a sub 3. What we're finding here is a sub 21. So we're starting kind of more down the line in the sequence, but it ultimately doesn't matter because we're just finding the next term, and they're giving you the term that they want you to start on. So we're going to go through this quickly, and then we'll be done with this in a moment. Basically, to find a sub 21, you would need a sub 20. Ooh, whoops, actually I have a little typo right there. We are trying to find a sub 21, and I just wrote down a sub 21, but we're trying to find a sub 22. So let me put a little 22 right there, and that's supposed to be 21. There we go. All right, so in any case, a sub 21, that was negative 1.4. We are adding 0.6 to that, so we get negative 0.8. And then to now find the next term, which would be a sub 23, let me just quickly edit that. We would need to take a sub 22 and just add 0.6, and a sub 22, that was negative 0.8. So again, you're just adding 0.6 each time, and you would get negative 0.2. And then again, to find a sub 24 now, we would need a sub 23. And you would take negative 0.2, add 0.6 again, and then you get 0.4. And then just keep adding 0.6 and you get 1. And that's how you do that one. All right, number 24. Really quickly, a sub n is going to equal a sub n minus 1, and the common difference d, you are taking away 2. So to find the next term in the sequence, a sub 23, you're just taking away 2 each time. So starting at negative 44, the recursive formula is saying minus 2. So a sub 23 is negative 46. Then take away 2, you get negative 48. Take away 2, you get negative 50. Those are the next terms. On 25, here's your formula. A sub n equals a sub n minus 1 plus 1.1. And then you are just adding 1.1 each time. So there are your next 3 terms. And then also in 26, there's the answer. A sub n minus 1 plus 1.8. And you are just adding 1.8 each time, and there's your answer. So all right, guys, there's the explanation of explicit and recursive formulas and how to use them and how to write them. Basically, if you have any additional questions, please come in or feel free to shoot me an email. And until then, I will see you guys later.